Okay, we're going to move into the second skill that we want to talk about here in the prerequisite chapter, which is solving quadratics. And so in your Algebra 2 class, you should have discussed 4 or 5 methods for solving quadratics. And so I'm going to demonstrate 2 of them for you here. In example 1, we have 5x squared minus 2x minus 3 is equal to 0. And so on this particular problem, I'm going to show you that this can be factored, and I'm going to show you how to factor it by the method called factoring by grouping. So the first thing is that when we do this, we want to look at the ends of this equation, which would be 5 and negative 3. And when we multiply those two numbers together, we're going to get negative 15. Then we want to look at the middle term, which is this negative 2 right here, and that's going to be my add number. And so now I am looking for 2 numbers that will multiply to negative 15 and add to negative 2. And if you think about it for a second, hopefully you come up with 5 and 3, except our 5 needs to be negative so that the numbers will add to negative 2 and then multiply to negative 15. And so what I do now is I take my ends of this equation, 5x squared and minus 3, and I write them down. And then in the middle, I'm going to have 2 x terms. One of them is going to have a coefficient of negative 5, and the other is going to have a coefficient of positive 3. And that corresponds to these 2 numbers that we found in that first step. The second thing I'm going to do is I'm going to group these parentheses together and then look to take out what's called a greatest common factor. So if you look at these 2 terms here, 5x squared minus 5x, we can take out a 5x from both of them since they have that in common. And when I factor that out, what is left? Well, from the first term, I have an x left, and from the second term, all I have left is a 1. Now, from the second 2 terms, 3x minus 3, I can factor out a positive 3, and that's also going to leave me with x minus 1. And that's how you know you're doing the question correctly, is if you see that the 2 inside parentheses end up being the same. And since they are the same, that's going to get written down as one of my factors, x minus 1. The other factor is going to come from looking at the outside pieces that we factored out, this 5x and this plus 3, and so that's going to be my second factor, 5x plus 3, and that's going to equal to 0. Now, we're going to use what's called the zero product property, which is we set both of these equal to 0 to get our answers, and so the first one is going to give me x is equal to 1, and the second one, when I set that equal to 0 and solve, I'm going to move over the 3 to make it become negative, and then divide by the 5 to get x is equal to negative 3/5. Now, on example 2, we can try to see if it will factor. So if we try to factor this, we multiply the ends together, which is going to give me a positive 5, and then look at the middle term, which is positive 2. Now, are there numbers that will multiply to 5 and add to 2? Well, the only 2 numbers that multiply to 5 would be 1 and 5, and those numbers do not in any way add to positive 2. And so, therefore, you cannot factor this particular quadratic. You're going to have to use either completing the square or quadratic formula. Now, which one you use is up to you. I'm going to show you completing the square, and the reason I like completing the square here is because that middle term has an even coefficient, and I can divide even coefficients by 2 really easily. And so I'm going to demonstrate for you here completing the square, but if you wanted to use quadratic formula, by all means, you would be able to do that. So when I do completing the square, I write down the first 2 terms, x squared plus 2x, and my objective is to add a number here that's going to make this quadratic factorable. And then the plus 5, I want that to be on the other side. So I'm going to move that constant over, and that's going to become minus 5, and I'm going to add the same number that I added to the left on the right side as well. And it follows the principle that whatever you do on the left side, you also have to do on the right. Okay, and so how do I figure out what needs to go over there? Well, here's what happens. I take half of my number that's in front of x. And so half of the number that's in front of x would be 2 divided by 2. and then I take that number and I square it. And so that's going to end up being 2 over 2, which is 1, squared, which is 1. And so that number is going to get added to both sides of the equation. Now, by adding that very specific number, which, in general we would say b divided by 2 squared, we are essentially completing a square. And so what I mean by that is that the left-hand side is now going to factor. So we would be looking for numbers that would multiply to 1 and add to 2. So numbers that multiply to 1 and add to 2 would be positive 1 and positive 1. So that would be x plus 1 times x plus 1, or another way to say that would be x plus 1 squared. And that's why it's called completing the square. Isn't that clever? All right, the right-hand side is now going to reduce to negative 4. And now I am going to take the square root of both sides. Now, when you take the square root of both sides, the squared is going to cancel, and I'm going to be left with plus or minus on the right-hand side. I'm going to have 2 answers here. The square root of negative 4. Well, the square root of 4 is 2, and since there is a negative underneath the radical, I'm going to have the imaginary unit, which we call I, and we're going to talk more about that a little bit later on in the notes. And so then finally, what would I do? I would get x by itself by subtracting 1 from both sides, and so that would be negative 1 plus or minus 2i. And if you use quadratic formula, you would end up with the same answer as well.